What's up, homies? It is Sunday morning, just before noon. Gonna see if I can make some more videos for you. I think I'm gonna start jumping around so that I can get through at least some of each type for you. So let's start with this one, piecewise function. I know a lot of you are unnerved by piecewise functions, but there's really no need to be. They are just functions that are defined differently for different x values. So let's look at the first definition of our function, x minus 5, when x is less than negative 2. So just think about graphing the normal function y equals x minus 5. It's a linear function, it has a y-intercept of negative 5, and it has a slope of positive 1. Now, when I'm graphing a piecewise function, I am going to take advantage of a couple ideas. One of those ideas is that this function is linear, x minus 5. A linear function means it's a straight line, and a straight line is defined by any 2 points on that line. So since I know it's starting at the x value of negative 2, and then it is going to the left, what I'm going to do is I'm going to plug negative 2 into my function for my x value. So I'm going to say y equals negative 2 minus 5, and I get y equals negative 7. That tells me that at the x value of negative 2, my graph has a y value of negative 7. So 1, 2, 3, 4, 5, 6, 7. All right. So I will put my first point, but I will put it as an open circle because the inequality says x is less than negative 2. It does not say it is equal to negative 2. So there's my first point, and this inequality is telling me where I should graph this line. I should graph it to the left. Well, if I'm going to the left, I need to look at the slope of this linear function. There's no coefficient in front of my x, so that means my slope is a positive 1. So if I was going to the right 1, I would go up 1, but I'm going to the left, so I'm going to go left 1, and I'm going to go down 1. So based off of this, I would have a second point somewhere about here. And then I can just draw in my line. And that right there should work for my left bit. Now, in the middle bit, I have an x squared graph. So now I am y equals x squared. So think about a normal x squared graph, but now only graph it between negative 2 and positive 3 x values. So if I'm an x squared graph, well, at the origin, it's at 0, 0. When x is 0, y is 0. When I go left 1, my graph would be up 1. Oh, sorry. I thought I paused. I was drawing lines. My bad, dude. Apologies. So if I go left 1, I'm up 1. If I go left 2, I'm going to be up 4 from that first point because 2 squared is 4. So 1, 2, 3, 4. There's my next point right there. It's filled in because it's or equal to. Let's do these symmetry points to the right. So I'm going to get a point there, a point up at 4. So there. And then when I'm at 3, I should be up at 9. So I should be all the way up here. And lo and behold, it does look like a parabola, except that last point actually should be a circle, an open circle. Again, because the inequality that says x is less than 3 does not say x is equal to 3. So now I can sketch in my curve, and I've done my middle piece. So now I just need to graph the red piece, which again is a linear equation, y equals 2x plus 2. So let's do the same thing we did before. Let's figure out where is the graph y equals 2x plus 2 when x is 3. So plug in 3. So y equals 2 times 3 plus 2. 2 times 3 is 6 plus 2 is 8. So I should be 1 point below this thing. So I should be about there. And then if I go 1 point to the right, I should be up 2 points from where I am because my slope is 2. So my next point is going to be up here. And then now I can draw in my line. And it's going to go on forever because it says x is greater than 3. So there you go. There is my piecewise function defined on 3 different intervals.